In this video, we're going to review the questions and solutions for the Chapter 1 test on equations and inequalities. So here, question 4, which is really the first question, wanted to check if you could evaluate. So here our keyword is evaluate. And we're going to plug in our numbers for our variables. So for C, I'm going to plug in -1. And for D, I'm going to plug in 5. So 3 times -1 is -3. Then you would do -3 minus 5, which is -8, which some of you put as your answer. But remember, these symbols mean absolute value. So the absolute value of -8 actually becomes +8. Here they wanted us to name the sets of numbers to which 3/5 belongs. 3/5 is a fraction. Remember, fractions are also called ratios, so this is rational. And a lot of you put rational, but you forgot all numbers are also real. So this one was rational and real. Question 6, the keyword was to simplify. So here you had to distribute and then combine like terms. So 1/3 times 15x. Remember, if you're multiplying 1/3, you're actually dividing by 3. So 15 divided by 3 would be 5x. And then 1/3 times -9, which is -9 divided by 3 is -3. 1/5 times 25x means you're dividing by 5. So you get 5x. And 1/5 times 5, again, you're dividing by 5. 5 divided by 5 is +1. Now you can combine like terms. So we have 5x plus 5x, and then -3 plus 1. 5x and 5x is 10x, and -3 plus 1 is -2. On the next question, we're solving. So here first, you had to distribute. 5 times 2x is 10x, and 5 times -6 is -30. Now I have variables on both sides. I usually undo the smaller one, so I'm going to undo 7x. So 3x minus 30 equals -3. Since the 3 is stuck to the x, I'm going to add 30. So we're undoing the -30. -3 plus 30 is 27. And then you could divide by 3. So for our answer, we get +9. Most of you did really well on this problem. The next problem 2, which is solving, but we have absolute value. Some of you here tried to distribute. Remember, when you have absolute value, you cannot distribute. It's like a boundary line. So you actually wanted to get rid of the 3 first. So since they're multiplying 3, you're going to divide 3. So again, we're starting by isolating our absolute value or getting it by itself. Now that the absolute value is by itself, you check if it's positive or negative. So here, since it's equal to a positive number, that means we will have solutions. Some of you just solved and got one solution. You forgot to separate this into 2 problems. 4x minus 10 equals 6, and 4x minus 10 equals -6. So if you didn't do that, that's probably why you got it wrong. You only put one solution. So here we could solve for x. Our first answer comes out to a 4, which some of you put, so I can already eliminate the first one. And my second one, which some of you forgot to solve, when you're done solving, it comes out to a +1. So our solutions are actually 1 and 4. And so a lot of students that got that one wrong just put 4. They didn't remember that absolute value has 2 solutions most of the time. On question 9, we're solving again. So absolute value of x minus 3 plus 10 equals 2. Remember, you want to isolate your absolute value. So I'm going to start by undoing the plus 10. Remember, you can't combine like terms. The absolute value are like boundary lines. So I need to do minus 10. Now you check what kind of number you got. Well, here we got a negative number. Remember, absolute value can't be negative. So since absolute value can't be negative, we have no solution. So the answer to this question was actually no solution. And so some of you actually separated that into two problems and solved, and that's why you got it wrong. Remember, you have to check if it is positive or negative before you separate it into two problems. Our next question checked that you understood inequalities. So we're solving. So I'm going to distribute. Negative 2 times 4w is negative 8w. And negative 2 times negative 1 is positive 2. From here, I combine like terms. And now I can start solving for w. Since these are stuck, I'm going to do minus 4 first. And then I can divide negative 8. And here's where a lot of students made a mistake. Remember, anytime you divide by a negative, your symbol's going to flip. So a lot of you forgot to flip the symbol. So it's going to change to less than or equal to. And 8 divided by 8, negative 8 is negative 1. So a lot of you put greater than or equal to negative 1 when the answer was actually less than or equal to negative 1. The next question also checks your understanding of inequalities. So here, we're going to solve for x. So I'm going to start by getting rid of my 3. So I get 6 is greater than 2x, then I can divide by 2. And I get 3 is greater than x. And a lot of you saw, okay, if I have my greater than symbol, then my circle is going to be unshaded. So a lot of you eliminated option 2 and option 4. And then here's where some of you went wrong. Remember, before you graph, you want your format to be correct. So your format should have the x in front. So a lot of you forgot to fix the format. And if you do that, it actually switches to x is less than 3. So since it changes to x is less than 3, when you graphed it, it actually should have been to the left, not to the right. So the answer was actually option 1. And a lot of you put option 3. So remember to fix the format. The variable needs to be first before the number. Our next question is also inequalities, but this is a compound inequality. So here we're going to solve. This is an and inequality since they didn't use the word or. So I'm going to separate it into two problems. Both will have the 4z plus 10.
I have to get Elijah a little Bayern jersey, bro.
Now I'm going to solve for z. I have negative 12 is less than 4z. If I divide by 4, I get negative 3 is less than z. On my next one, I'm going to subtract 10.
I should check the Adidas outlet.
Then I divide by 4. So I get z less than or equal to 2.
What do you think?
Remember, you want to graph these just to make sure it's not a special case. So I'm going to do my graph.
I think they're Adidas.
This one I'm going to fix the format so it becomes z greater than negative 3.
Yeah, the outlet's pumping.
Z greater than negative 3 would be an unshaded circle to the right. And z less than or equal to 2 would be shaded to the left. Here they intersect between negative 3 and 2. And since it's an and, you put it back together. Negative 3 is less than z is less than or equal to 2. with the less than symbols because you're going from least to greatest. A lot of you put the one that had 1/2 there, and that's why you got it wrong. On our next question, a lot of you missed this one. So this one, please check it carefully. So this is an OR inequality. Our keyword says to solve. So I have 5x minus 4 greater than or equal to 26, or 29 minus 3x greater than 2. I'm going to solve my first one. So 5x greater than or equal to 30. If we divide by 5, we get x greater than or equal to 6. Then it says OR. I'm going to solve my second one. Here we're dividing by -3. Remember, when you divide by a negative, your symbol flips. So it's actually going to change to x less than +9. So a lot of you put the answers that had 6 or 9, but you forgot to graph it. Remember, you always want to graph to see if it's a special case. So I'm going to set up my number line. I have 6 and 9. And since this is an OR, you graph them on the same number line already. So x greater than or equal to 6 would be shaded to the right. And x is less than 9 would be unshaded to the left. So here, everything ended up shaded. Remember, when everything ends up shaded, your answer is all real numbers. So a lot of you, since you didn't actually graph it, you put the wrong answer. Some of you put the one that had OR, but if you look here, it's x greater than or equal to 6, not less than or equal to 6, and it's x is less than 9, not x is greater than 9. And then the first answer was for an AND problem. This was not an AND problem, it was an OR. So our answer was all real numbers. Our next problem is an absolute value inequality. We're going to solve. Absolute value of 2x minus 3 is less than or equal to 7. Here the absolute value is already by itself. So we're going to separate it into two problems. Here you have to check your symbol. Since it's less than, remember it's an AND problem. So on these you have to check if it's an AND or an OR. So I have 2x minus 3 less than or equal to 7. And 2x minus 3 greater than or equal to -7. Remember, on the second one, you flip the symbol and change the sign. Now I can solve. Once you get your two answers, remember you want to do a number line to make sure it's not a special case. So I have -2 and 5. And since this is an AND one, you want to graph them separately and see where they intersect. So x less than or equal to 5 would be shaded to the left, and greater than or equal to -2 would be shaded to the right. So they intersect between -2 and 5. So when you put your answers together, it would be -2 less than or equal to x less than or equal to 5. Most of you did well on that problem, and then a lot of you needed help on this last problem. So this last problem we're solving. Remember, you want to isolate your absolute value first. Don't distribute. You have to get rid of the 2. So they're multiplying. We divide by 2. Once your absolute value is by itself, check your symbol. This is a greater than symbol. Remember, greater sounds like great or. So this was an or problem. So right away, I would have taken out the first answer choice because that one was an AND answer choice. Some of you put the first answer choice, and that's the reason you got this one wrong, simply because you didn't check if it was an AND or an OR. From there, I'm going to separate it into two problems. n plus 7 is greater than 4, or n plus 7 is less than -4. And we can solve these two. So I have m greater than -3 and m less than -11. Some of you put the last answer. If you look here, sorry, some of you put the second answer choice. If you look at your symbols, let's check it. This says less than negative 13. We didn't get a negative 13. And then m greater than negative 1. We didn't get those. So that one was right away wrong. From here, I'm going to graph it just to make sure it's not a special case. So I have negative 11 and negative 3. And since it's an OR, you graph them on the same graph right away. So m is less than negative 11. Would be unshaded and to the left. M is greater than negative 3 would be unshaded and to the right. And then you would just put them together with the word OR. So our answer was the last one. Again, a lot of you put the first answer choice there, which was actually an and that's why you all got it wrong. So less and, great, or make sure you're checking your symbols with absolute value inequalities. You can review this video to help you do KMAS on your test if you need to correct it. Just make sure you turn in those corrections by the end of the week.